Hi there, this is Steve Earth, and this is my video response to Matt Parker's Stand-Up Maths card trick. So I thought I would explain very briefly his trick. I'll put the link to his original video in the doobly-doo. Essentially, the trick is you have the spectator choose any number of cards from a deck. I just happen to have 10 listed here, but it turns out this is completely general. And also some word where the number of letters in the word is at least half the number of cards that have been chosen out. So for this particular example, since I have 10 cards here, I'm going to be doing a demonstration as if it's 7. But in fact, it turns out, and you're going to see why in my proof, that any number which is at least half does in fact suffice to get it to work. So the trick is that you perform a certain kind of shuffling of the cards, where you pull out one card at a time from the top of the deck, putting it face down, spelling out each letter of the word as you go. So in this case, there'd be 7 cards coming down. And then after you spelled out the words, you've got some number of cards left, and you just pick them up and put it on top of the pile. So there were 2 questions that Matt Parker asked about this. So the first is, why does the bottom card go to the top after performing the shuffle 3 times? And again, I don't actually mean a normal randomized shuffle. This is following this particular algorithm of putting one card at a time from the top down, and then putting the remainder cards on top. And yeah, I'll demonstrate that in a minute. So it turns out if you do that 3 times, provided that the size of the word is at least half the size of the cards you're dealing with, in fact it is true. And then he had a second question. He says, why does the deck, he said usually, return to its original order after 4 shuffles? I actually have an explanation that I believe shows that it always does, and there isn't a counterexample. It has to go back after 4 shuffles. So I sort of, as soon as he put out that video, I was thinking, what's going on here? And at first I had a rather elaborate way with using permutations, permutation cycle notation of showing why this is true. But then I realized I think a much easier and intuitive way to think about this problem is to do it pictorially. So I actually have a picture which I think really clearly demonstrates what's going on. And to do this, what we have to do is imagine this deck right here is actually a flower. So there's our flower. So the idea is that in the flower, there's sort of 3 parts to the flower. So there's the part that's underground, there's the roots, then there's the long green stem, and then there's the flowery petals at the top. So the idea is that these correspond to different positions in the deck. And then by looking at these different positions and seeing how they get affected by this shuffle, it should actually answer the questions. I'm going to actually answer the second question first, and then it turns out the answer to the first question follows as a corollary. So so let me explain the purpose of this flower thing. So there's going to we're going to consider 3 different regions of the deck. So the above ground part of the flower, which is the flowery petals and the stem, so that is the part that represents the word that you're going to be counting out. So in my case, so the entire flower all together, all 3 parts, is all these 10 cards right here. But again, it doesn't have to be 10, it could be any number. So the stem and the flowery part at the top are the 7 cards that represent the words from the top. The part that's underground is the remaining part. So in this case, there'd be 3 cards that are at the underground, and those are the parts that kind of get put to the top, not one at a time, but all together in a clump, preserving the order, that go to the top. So what is the above ground part? Why is that split into 2 parts? Well, however many cards are in the root, that's also the number that you're going to assign to the petal flowery part at the head of the flower. So in this case, we know the cut is 7 and the whole deck is 10. So that means there's 3 cards in the root, which means there's also going to be 3 cards at the head in our region. So I think it's better to kind of color code these regions. So let me go ahead and do that. So let me get the questions up here and put on these different zones. So we already know the bottom 3 cards. I'm sort of separating them out. Now, I'm not saying actually put them into separate piles here. This is just kind of envisioning it as if it was split up. But really, it's still all one big deck. So let's perform the shuffle once on the deck, just so you can kind of get a feel of what's going on with the different regions. So here are the 10 cards all sort of stacked up, where 1, I don't know if you can see the little numbers here, but 1 is supposed to represent the top card, and then 1, 2, 3, all the way down to 10. All right, so imagine we've got our 7-letter word. So we're going to start by grabbing the top card, and I'm actually going to leave the image of the cards here and just be grabbing the numbers so we can kind of compare where the new positions are compared to the old positions. So the first thing is we're going to grab the top card and move it to this new spot down here. So notice the top card, which was the very top of the flower, is now, it was the tippy top of the red zone here of the petals, but now after we do it, it's the bottom lowest part in the brown zone in the roots. So that's card number 1, and then we have to do it again for card number 2. So we grab the second card, and we put it down again, face down, dealing 1 at a time. So it's going to go on top of card 1, and then we do it again for card 3. So grab card 3, put it face down on top of the others. So notice my brown zone is now filled up. I've covered up all the roots, and I'm also finished the petal part. So the petal part is now gone. The flowery part is now where the roots are. But I got to keep on going because that's only 3 cards, and we said that the word has a length of 7. So I've got 4 more cards to go, and notice that's the exact length of the stem right here. So I got to grab the 4th card, and the 4th card continues to go on top. And then I also grab the 5th card, which goes on top. And now 2 more cards left to form the 7-letter word, which will exactly finish off the stem, so I'll just quickly do 6 and 7. And again, I'm just leaving the picture, the images of the cards still here in the deck for comparison's sake. But in reality, of course, they would all be moved over here on the right as you go through. All right, so we've now got the 7 cards, 1 at a time, pulled off the top, and that's our word. So notice the root, the brown zone is all filled up, and the stem is now filled up. And all that's left of our original deck is this section at the bottom of the roots, and all 3 of these cards are no longer counted one at a time, are going to just be plopped directly on top of all the rest, preserving their order. So let me go ahead and do that. So grabbing all of these at the same time and pluck. So notice what used to be the root, all these 3, now completely fills up the red zone. So the brown zone, which was the roots, becomes the new flowery part of the petal, and it's similar to what happened before, but notice that the order here got preserved. So here it was the 8 on top, then the 9, then the 10, and that's what happened here. So let me do a little recap of comparing the new order of the cards after a single shuffle compared to the old order of the cards. So before I do the comparison of what happened with the different zones, I just want to point out that in order for this picture to make sense, it did have to be true that the size of the cut was at least half the size of the deck that you're playing with. In this case, the cut size is 7, and so we have to do a cut of at least 5, and we did 7, so we're okay. Now, why does this picture fail? So remember the way I made the size of the petal part was by looking at the roots, seeing how many cards were left over, and kind of counting down from the top of the flower and making that. So it turns out if it this 3 cards that were left over, if the cut had been, say, less than 5, let's say it had been 4 and there were 10 cards, then that would mean this leftover part would be 6. So in that case, the 6 would have overlapped the entire, there basically would have been no stem, and the red zone would have overlapped into the brown zone. So that's no good. So this way of looking at it, in fact, only works if the cut size is at least half the size of the cards you're playing with. All right, so let's take a look and see what's going on. Let's look at the stem first, because I think this is the interesting bit. So if you look at the stem, it was the cards 4, 5, 6, 7, and here, 7, 6, 5, 4. The stem stays the same. It never actually moves. The only thing that happens is it basically turns upside down. It's the only effect on the whole thing. Is, I know the image makes it look like the sun's underneath, but just kind of read it 7, 6, 5, 4, just like over here. So every single time you do the shuffle, the green zone stays in the green zone. So if we were to do it again, it just flips upside down again and stays in the green area. So the green portion of the deck, the same cards never leave. The green stuff never goes to the red or the brown. The brown and the red never enter the green. The green stays in the stem stays in the stem, but every single time you do the shuffle, it turns itself upside down like that. Okay? And again, I'm just demonstrating it with 10 cards here, and as if the cut size was 7. This is true all the time, these different regions. All right, well, what about the red zone and the brown zone? What's happening with the roots and the petal? Well, the 1, 2, 3 was the flowery part, but we counted out, it went right to the roots, and that's why we made sure that the flower and the roots were the same length. That's why we did that. So it turns out what's going on here is the red zone moves into the brown. The red becomes the brown, but when it does it, it turns itself upside down. Oops, sorry, moved off the screen there. Didn't do that. So instead of before, the order was 1, 2, 3 from the top down. Now it's 3, 2, 1. Well, what happens to the old brown zone? Well, the old brown zone becomes the new red zone. But this time there's no flipping. Because remember, the way the quote shuffle worked was it just goes directly on top. So when the brown becomes the red, the order stays the same. When the red becomes the brown, the order is inverted. The order is also inverted with the green zone, but it stays where it is. All right, so really, once you know that, that pretty much answers all the questions. All the shuffles essentially do that. The red and brown zones flip, but when the red moves to the brown, it turns upside down. The brown becoming moved and moves up to the red zone, stays the same order. The green stays where it is, but turns upside down. So what does that effect look like if we do the shuffle 4 times? Well, in the case of the stem, we know it stays in the same position in the deck, and the only thing that happens is it gets flipped. So on the first shuffle, it stays where it is, but it's upside down. And then the second shuffle, oh, it's right side up again. Third shuffle, upside down, and the fourth shuffle, upside up again. So with 4 shuffles, the stem, the middle cards right here, are perfectly intact. Well, let's take a look at the red zone. So what's happening with the red cards? So the cards that started off in the petal part of the flower, so in the first shuffle, they go down to the brown, but they're upside down. So next shuffle, they go back to the red, and they stay upside down. Third shuffle, they move back to the brown, but get turned upside down again, so now they're right side up in the brown zone. And then lastly, for the fourth shuffle, they move back to the red and preserve the order. So remember, brown to red preserves the order. So that is the correct order there. Well, it would have been had I put the... Okay. So I think you guys get the demonstration. The problem was I had the bottom up there. So how about I do it correctly with the bottom part, so that way you'll get the idea of what's going on. So let's follow what's going on with the thing in the correct order this time, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and let's follow the initial roots. So it starts like this. So remember, after the first shuffle, brown goes to the red, and the order gets preserved. That's the first shuffle. Second shuffle, it goes back to the brown, but now it's upside down. Next shuffle, so we're on the third shuffle, it gets moved back to the red, and the order's preserved. The upside down order's preserved. And then for the very last shuffle, it goes back to the brown, but gets turned upside down again, but since it was already upside down, it gets turned right side up. So there we go. It doesn't matter what region the card was in, every card gets returned to its original place. So that answers the second question about why is it when you do 4 shuffles, everything gets back to where it was. So what about the initial trick, which is if you do it 3 times, why does the bottom card become the top card? So again, just using the same idea of the regions, let's just only follow the one card, right? So whatever your bottom card is, you're at the bottom part of the brown, the bottom part of the roots of the flower. So the first shuffle, order's preserved, you become in the red zone, which would be the bottom part of the red flower here, because the order gets preserved. So the second shuffle, you get moved to the brown, but upside down. So now you're the top part of the brown, because you got flipped upside down. So, and then the third shuffle, order gets preserved, you move back to the red, so instead of the top of the roots, Now you're the top of the flower. Hence, doing the shuffle 3 times does in fact put the bottom card on the top, and that is why the trick works.